Hey guys, welcome back to YT Classroom. Today we are looking at IGCSE Computer Science Paper 1 Variant 2 from May June 2024. If you are new to the channel, do not forget to like, share and subscribe to the channel for more upcoming videos on the May June 2024 paper series. So in this video, I'll be taking through a detailed solution of this whole paper and explaining you each and every question so that you are able to understand all of these questions and also master in your exams. Let's start this. This is the most recent paper for 0478 computer science and also goes along with the syllabus changes in 2023. So if you're appearing for the mid-June 2025 series or the October-November 2024 or anyone after this, it's very important that you do solve this paper. Alright, so let's start now. This is paper 1 and this is for 1 hour and 45 minutes and there are 75 marks on this paper. So the first question says that data can be measured in bits. Give the name of the data storage measurement that is equal to 8 bits. Now this is a theory question, the basic question. Whenever we have 8 bits, it's basically 1 byte. 1 byte is equivalent of 8 bits. So that's what we're gonna write here, 1 byte. There it says how many bits are there in a kilobyte, in a kibibyte. Now in 1 kibibyte you have basically 1024 bytes, but it does not say bytes, it says bits. So basically we know that in 1 kilobyte we have 1024 bytes, and in each byte we have 8 bits, right? So we have to multiply 1024 into 8. What will we get when we do this? You basically can do 1000 into 8 is 8000 and 24 into 8 is 192. So 8192 bits. Alright, I hope it's clear. Just repeating, 1 kilobyte is equals to 1 kibibyte is equals to 1024 bytes, and each byte is equals to 8 bits. So I've multiplied 1024 by 8 to get 8192 bits. Then it says that give the name of the data storage measurement, which is equals to 1024 gigabytes. Now, if you look at the order, every time you have 1024, for example, 1024 bytes is equals to 1 gigabyte, then 1024 gigabytes is equals to 1 megabyte, then 1024 megabytes is equals to 1 gigabyte, then 1024 gigabytes would be equal to 1 terabyte. So it just keeps on increasing. So for this, 1024 gigabytes is basically 1 terabyte. Alright, now I hope this is clear. Now it says that a 16-bit color image, that is 16-bit is talking about the image, basically the color resolution or the bit depth, has a resolution of 512 pixels into 512 pixels. So resolution is given here and the color depth is basically 16 bits. Calculate the file size of the image in kilobytes, kibibytes, show all of your working. Now 16 bits basically means that in order to represent each pixel of that image, you're using up to 16 bits, which is 2 bytes. So first of all, let's calculate the file size in bytes, okay? First of all, we will write that the resolution that we have, the resolution in pixels is basically 512 into 512. You don't need to solve this, but we just need to show that it's there. So file size in bytes. File size in bytes. Why do I have to write in? Okay, file size in bytes would be equal to 512 into 512 into basically 2. Now if you're wondering where did I get a 2 from, the formula for calculating the file size of an image is that you multiply the vertical number of pixels by the horizontal number of pixels, which are 512 by 512, into the color depth, or into the color depth or bit depth. That is 16-bit here, right? Now 16-bit basically, I told you, it means that for each color or each pixel you're using 16 bits to represent that. So 16 bits is basically 2 bytes. I could use 16 to get my answer in bits, and then I have to divide my answer by 8 to get my answer in bytes. But by replacing 16 bits with 2 bytes, I'm removing that step and directly getting my answer in bytes. Okay, I hope this is clear. Now moving on, I need my answer in kibibytes, so I would divide this by 1024. File size in basically kibibytes would be, you have to divide this whole thing, 512 into 512 into 2 divided by 1024. Now, often because you're not allowed to use calculator, you would get messed up with such a big calculation. So here you need to think of some mathematical steps in order to simplify this. Now, I would just write here. You don't need to show this; it's just understanding. I can write the first one, the numerator part as 2 into 512 into 512. I haven't done anything. I just wrote it in brackets. And 1024 can be written as 2 times 512, because when you double 512, you get 1024. Right now, if I see, I can cancel out 2 and 2. I can cancel out 512 and 512, and I'll only be remaining with 512. So my answer is 512 kilobytes. 512. So often all of these calculation questions do have this kind of technique. So try to find this technique, otherwise you'll have to spend a very large amount of your time on this calculation. All right. Now moving on, it says question number 2, data can be transmitted from one device to another. Take one box to show which of these terms is not a method for transmitting data. So serial is one, simplex and parallel, but parity is not. Parity is like more like a check to ensure that the data has not been corrupted during transmission. Serial and we have parallel as well as simplex, etc. All of these are methods of transmitting data. Serial would mean one bit is sent at a time using one bar channel. Parallel with multiple bits are sent using multiple bar channel. And simplex means the data is being sent in only one direction. Data is broken into smaller units to be transmitted from one device to another. Give the name of the unit the data is broken down. So when we break down data, what is that unit called? That unit is basically called as packets. It says name, so I just say packet. Easy question still now. Now it says that data is often encrypted when it is being transmitted from one device to another. Explain how data is encrypted using using symmetric encryption. Now the key to understanding symmetric encryption is that you use the same key to encrypt and decrypt the data. So that is a very important point. That is the main difference between your symmetric encryption and asymmetric encryption. So my first point is going to be that data is basically encrypted. Data is encrypted, and you would encrypt the data and decrypt the data, decrypted using the same key. So this shows that you're talking about symmetric encryption using the same key. Then you got to say basically that you're going to use an algorithm. So data is encrypted using an algorithm. Data is basically encrypted using an algorithm. And what in that algorithm, what is it basically based on? It's basically based on a key, that encryption key that we're talking about, that uses a key. All right. Now the next thing to talk about is basically that when you apply the key to the data, the plain text is basically encrypted to ciphertext. All right. So when the key, or you can say rather than writing that applying, because it will be done mostly through software, you can say that the plain text is basically the text that you have before encryption is encrypted. The plain text is basically encrypted. The plain text is encrypted to ciphertext. And ciphertext is basically the one that is after the the encryption, ciphertext. And even after you transmit the data, is going to be decrypted as well. The plain text is encrypted to ciphertext. Okay, was there transmission involved? Yes, the plain text is encrypted to ciphertext, and data is transmitted. Then we need to include one more step, that is after you transmit, after you basically data has been received, after the data is received, the ciphertext is, you will have the ciphertext which is encrypted form. You will have to decrypt it, is basically decrypted to plain text. Now you'll have this plain text using the same key, plain text using the same key. same key. And so that means that if you want to use the same key, that means you also have to ensure that the key is transmitted to the receiver along with the message. The key is basically transmitted to the receiver. The key is transmitted to the receiver as well. All right, so I hope this is clear. You guys should take your time and read this question. Just going to read the answer. Data is encrypted and decrypted in the same key. Data is encrypted using an algorithm that uses a key. The plain text is encrypted into ciphertext and the data is transmitted. After the data is received, the ciphertext is decrypted to plain text in the same key, and the key is transmitted to the receiver as well, because only when you transmit, this receiver will know that what encryption has been applied. Now it says give one purpose of encryption. So the main purpose is that when you encrypt something, it makes the data meaningless except for those who have the encryption key. So you can say encryption makes the data meaningless, makes the data meaningless. That means basically once you encrypt it, it's going to be a mix of a jumbled up of words which will not make any sense unless you decrypt it using the same key. It also helps to make the data more secure, so that could also be a point. But here it's only also 1 point, so you only have to measure. Now we are moving on to question number 3. Question number 3 says that binary is a base 2 number system. Give an example of a number system that is base 16. A base 16 number system is basically called as an hexadecimal number system. And this is a part of topic 1, chapter 1 of your P1 syllabus. Then it says that 3 binary numbers are entered into computer. The computer converts these numbers and stores them as binary. Give the binary number that will be stored for each of the binary numbers. So there are some binary numbers given here, and you have to convert them into binary. So first of all, what you're going to do is write down the column headings for binary: 128, 64, 32, 16, 8, 4, 2, and 1. So first of all, for 10, now you have to find the number that is below 10, the lowest number, basically the nearest number to 10 but below 10. That is 8 here, so I'm going to put 1 here. When I do 10 minus 8, I get 2, so I'm going to put 1 here. The rest are going to be zeros, so I'm going to write 0, 0, 0, 0, 1, 0, 1, 0. Alright, now moving on for 50. The lowest number I see that below 50 is 32. And when I do 50 minus 32, it gives me 18. 18, the lowest number below 18 is 16 here. So when I do 18 minus 16, it gives me 2. And I already have 2 here. 2 minus 2 is 0. Rest all are going to be zeros. You can again check, because when you do 32 plus 16 is going to be 42, and 6, 48. 48 plus 2 is 50. So 0, 0, 1, 1, 0, 0, 1, 0. Then you have 201. For 201, the lowest number I see is basically here, that is 128. Now 130, when I subtracted 71, it's going to be 73. Yeah, because 30, so 71, 73. Now when I do 201 minus 128, it gives me 73. 73 minus 64 is going to be 9. All right, so I'm going to put 1 here and 9. 9 minus 8 is basically 1, and 1 minus 1 is 0. Let me check this up to ensure that I have no errors. 128 and 64, that's add up to 192. 192 plus 8 is 200, and then 201. 1, 1, 0, 0. And then the rest of it would be 1, 0, 0, 1. 1, 1, 0, 0, 1, 0, 0, 1. It says that explain why is the data converted to binary by the computer. Now there's a very simple explanation, because computers use logic gates, or you have these your computers basically function on logic gates, and these logic gates can only process values 1 and 0. You have learned this in chapter 10. So that's why we're going to write this here. Computers, they use logic gates, including AND or NOR gates, and logic, not notes, I mean logic gates that can only process values, that can only process the values of 0 and 1. The values of 0 and 1. If you guys aren't clear, let me explain again. Now basically in a computer you have a lot of logic gates. Logic gates include, so when you give them an input, they can give a certain output, and in logic gates you can only have take two inputs, either 0 or 1. That's why all the data that you put in a computer is basically created into logic, is converted into binary, so that it can be processed by the logic gates. In your computers you also have a switch. Now, a lot of computers do have a lot of switches in their internal component parts, and as you know, a switch can either be on or off. So, on is given by 1 and off is can be given by 0. So, you can also say that computers use switches that have only two states, on and off, on being represented by 1 and off being represented by 0. Therefore, you convert them into binary. Now, the next part says that the two binary integers, these you have given, they're added up together. Add the binary integers to the binary addition and show your answer in binary, show all of your working. So it's simple. You're gonna write them clearly: 0 0 1 1, 0 0 0 0. All right, 8 numbers: 0 1 1, 0 0 1 1 0, 0 0 1 1 and 4 zeros: 0 1 1, 0 0 and 1 1. No, okay. So it's always a good idea to check your numbers to ensure they're not gonna make any mistake. Just gonna check. Yes, that's correct. And 0 1 1 0, 0 1 1 0. That's correct. Now when I'm adding this up, what will I get? 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 is 10, so 1 carry over, 0 here, 1 plus 1 is again 10, and 1 is going to come down. So I'm getting 1 0 0 1 and 0 0 0 1 1 0. So that's going to be here 1 0 0 1, 0 1 1 0. Moving on, it says that the denary integer negative 32 is stored as a 2's complement integer. Calculate the 2's complement integer that was stored, show how you're working. So for first of all, in order to show negative 32, you have to show 32 first. 32. Now, in order to write 32, what you're going to do is 32, basically again, you take the columns 128, 64, 32, 16, 8, 4, 2, 1. So now to represent 32, 32 would be 1 in here. So you just say 32 is equals to 0 0 1 0 0 0 0 0. Then what we're going to do is we're going to invert them. So that is called as where you're going to invert all of these values. So 1 1 0 1 1 1 1 1. So basically where there's a 1, you're going to replace that with a 0, and where there's a 0, you're going to replace that with a 1. There's only one here, so I'm going to change that to 0, and rest all of them are 1s. Then the next step would be to take this value, which is 1 1 0 1 1 1 1 1, and add a 1 to this. Alright, so 1, what is 1 plus 1? 10. 1 plus 1 is again 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 10. This is going to be 1 1 1. So my answer is going to be 1 1 1 0 0 0 0 0. I hope this is clear. Now moving on to question number 4. It says a student uses both system software and application software on the computer. Give an example of system software. So I'm going to write here operating system, or you could also mention certain type of utility software, or you can say utility softwares or certain type of utility softwares. But I'm going to mention operating system since it's the one which is most easiest for me. Give two types of application software. Application softwares include basically simple applications. So this could be like a word processor. Do not write Word document, that's not valid, but word processor is valid since there are many other. Word document is basically a type of word processor. And you can also say spreadsheet, that is Excel maybe. You have databases, the Microsoft Access, a spreadsheet, and then your web browsers, your photo editors, video editors, your games, and social medias, a lot of apps. Then it says describe the difference between system software and application software. So the main difference is that the system software that you have, it's basically going to manage the computer's software and hardware resources, whereas the applications allows the user to perform tasks. You see, operating system is not something that you use directly, but it runs on the background of the computer, and it's critical if you want to use the basic functions of the computer. Whereas word processor and spreadsheet is something that you or any computer user might use on their everyday life. So basically, system software, as you see, system software, what it does is that it manages or manages the hardware and the software resources of a computer, the hardware and software resources of a computer. So that's the purpose of the system software, to manage the hardware and software resource of the computer. The application software allows the user to perform certain tasks. The application software allows the user to perform certain tasks. The user to perform certain task. If you want to perform a certain task, you can perform that using the application software. System software is basically going to manage the hardware and software resources, whereas application software allows you to perform certain tasks. Now, here's question number 5 is all about the fill in the blanks, which is for 7 marks, so you should score good marks. It says that instructions are processed by the CPU in a computer, and we are going to use these words to fill out this. It's complete the paragraph about fetching an instruction into the CPU to be processed and use the terms. Some of the terms will not be used, but you cannot use the term more than once. Let's start doing it. The program counter contains the dash of the next instruction to be processed. The program counter, basically the whole process of starting is that it's the program counter has the address of the next instruction, the memory address of it. So we're going to say address of the next instruction to be processed, and this will be basically sent to the MAR, which stands for memory address register. Memory address register, MAR. So basically this MAR register, what is does that it holds the address with which we are working now, with which data is being read or written to. The memory address data is written to. The address is then sent to the this address you will basically send it to the RAM, so that you can work it out using the address space. Then the address is sent to the RAM, the random access memory. Alright, now why is this important? This is important so that you can basically extract the data or extract the address that is stored on this memory address in your computer's memory. Once the address is received, the instruction is stored and is sent to the memory data register. The memory data register will store the instruction that is data that you're currently working with, or it has currently been read or written to. The memory data register, the MDR, it basically stores the data that has been read from the computer memory or about to be written. Alright, so sent to the memory data register, that is MDR. Using that, what bus do you use here? You basically use the data bus because you're carrying data. The instruction is then sent to the CIR, which is the current instruction register. Current instruction register, that is built into the control unit. You basically the CIR is built into the control unit, which is called as CU. Let me read it again. First of all, you have the address of the instruction in the program counter that is moved to the MAR in the address space. Then you will send that to the RAM. Once the address is received, the address is received, that is like the data, or the address is received, is sent to the memory data register, is the data bus. Then it's into the current instruction register, and this current instruction register is where it's processed, and it's a part of the control unit. The CPU uses an instruction set to decode it. You use an instruction set. So what is meant by instruction set? So simply, instruction set like a list of those machine code commands that the CPU is able to process, because there's a very limited range of these opcodes that the CPU can process. So these are all defined in the instruction set list. So we can say that it is a list. It is a list of machine code commands, which are also referred to as opcodes, machine code commands that can be processed by the CPU. That can be processed by the CPU. Alright, so hope it's clear. Instruction set is like a list which has it's a list which has the machine code commands or the opcodes that can be processed by the CPU. There's a limited range of these opcodes that can be processed, and these are defined where in the instruction set. So whenever an instruction contains of opcode and operand. So opcode refers to what is the instruction, which is referred here. The operand will refer to the data which has to be acted upon when you're doing this. Now let's move on to the next question. This question says that there are some statements given about error detection methods. You have to complete the table by giving the correct name. And this is 5 marks, so use it very carefully here. First of all, it says that an or or even process can be used. Obviously, this is parity byte or parity check. So that is when you decide on what parity do you want to use for all of your data. And for example, if you use an even parity, that means an even number of ones in all of the bytes you send. There's a parity bit reserved for that, so that you can check, you can change the bits to ensure that they're all even. And then the receiver is going to check the same thing. If it changes, that means there's a corruption. Now it says the value is collected from the data using algorithm. This happens before and after the data is transmitted. This is basically called as checksum. So when you will calculate the value and you recalculate the value, and if these both values match, that means no error is occurred. A copy of the data is sent back to the receiver. This is called as echo check. Once it's received by the receiver, no, basically the sender sends the data to the receiver. The receiver will send back the data, and the sender will compare the two sets of data in echo check. Acknowledgement and timeout is this is basically ARQ, which stands for automatic repeat requests. Automatic repeat request. So basically, in that what happens is that the sender is going to send the data, and then it's going to get the acknowledgement. If the data has been received rightly, you send a positive acknowledgement, the receiver. Otherwise, you send a negative acknowledgement. However, there's a certain time period in that if no acknowledgement is received, the sender is going to send the data again until an acknowledgement is received or a maximum number of retransmissions have been taken place. Now it says the values appended to the data that has been calculated in the data. The value is checked on data entry. It's appended to this data. So whenever it's all about appending, so it's always check digit. Alright, check digit. You will attach it to the end of the data, and this will be recalculated. Or there are methods which check that all the values go together. Parity check for odd and even, checksum. You calculate the value from the data using the algorithm, and this happens before and after the data. And basically the algorithm used is same. Echo check, you will send the data back. ARQ I've just explained right now, and check digit is the value that you attach to the end of the data. So now we are moving to question number 7. Now we'll be moving on to question number 7. Question number 7 says a computer is both a media access, a MAC address, and an IP address. Take one box to show which of the statements is correct about MAC address. It is assigned by the manufacturer, yes. It is assigned by the router, no, because MAC address is always assigned by the manufacturer at the manufacturing stage, and can be found on the NIC card, which is a part of the hardware of the device. It's not assigned by the router. It can't be static or dynamic. It can be UAA or LAA, that is universally administered and locally administered. It's made up of 3 different parts. So it's made up of 2 different parts. The first half representing the company, that is the manufacturer's code, and the second half is the serial number of the device. Now it says that an IP address can be an IPv4 or an IPv6, as we all know. Give an example of an IP address in an IPv4 format. Now in IPv4, it has basically 4 groups which are separated by dots, and each of these groups is basically 8 bits, and you have to write that in denary. So basically 4 groups which will have 4 different denary numbers, and these numbers can be from 0 to 255. So I could say 125 and then maybe 97.26. Maybe 213. Alright. Now the second part says give 2 characteristics of the IPv6 format. Now IPv4 address is 32 bits, whereas IPv6 address is 128 bit. So that's one property that you're going to learn, that is it's 128 bits. 128 bit address, and because it's 128 bit address, we write it and basically use it in presented or represented using hexadecimal. So represented using hexadecimal. So how does an IPv6 look like? It's basically that you'll have 8 groups, each consisting of 4 hexadecimal digits. When you say 4 hexadecimal digits, that means 16 bits per group, and 16 into 8 would be 128. So that would be the IPv6 format. It's represented using hexadecimal. It's 128 bits, and those 8 groups that I'm talking about, it's basically separated by colons. Each group has 4 hexadecimal basically digits, and they're separated by colons, and 8 groups. Alright, so I hope this part is clear as well. This is very easy scoring score, and this always is there, so make sure you do learn this topic well. Now question number 8. A company has a website that is suffering from a distributed denial of service attack, DDoS attack. So it says that draw another diagram to show the process of DDoS. Now, what is a DDoS attack? DDoS attack is when basically there's a third party or there's basically a computer which sends a malware to a large number of everyday computers. So what happens is that this will turn them into botnets, and then these all computers, the main computer which was sending the malware, it'll force all of these computers to send requests to a web server at the same time. And the web server cannot handle a large amount of requests and therefore crashes, and it cannot respond to the genuine requests coming from the user. To another diagram, these diagram questions have been asked in almost every paper since now, so you have to make sure you practice as many as you can. So first of all, it would be a third party. Just give me 1 minute. Yeah. So third party, you basically have a third party which can be a computer or let's say a server. Third party. This is your one computer. All right. Now this is basically going to, what is going to do is that third party is going to send malware. Third party, it sends a malware. Now who does it send it? So you have various number of devices which are called as bots. So this could be a bot, this would also be a bot. I would draw at least 4 to 5 of them, although in real life it can be a very large number. Bot, and I would represent individually. So these are like devices that might be your device as well. And then when you make all of them bots, so by sending the malware, it'll create something which is called as a botnet. So they're in a group now, or example a team now. So this is what you call a botnet. Now what does it do? It sends malware to each of them. So going here, malware going here, malware going here, as well as malware going here. After that, what happens is that you will have a web server in the side, a web server. So these all are going to send requests to it. What are these? These are requests. Now because a web server only has a limited capacity, can only respond to limited number of requests at a time. So web server basically cannot handle the large number of requests, Therefore, now if you cannot handle something, it's going to basically crash and cannot respond to genuine requests, and cannot respond to genuine requests from the users. Now there are basically two formats of this DDoS diagram that have been the marking scheme. So this is the one I'm done now. It's very similar in the marking scheme of this paper, but there's another one which is again very similar one, and you could check that it's in the older papers, and I think it's in one of my videos as well. It says that identify a solution that can be used to help prevent DDoS attack being successful. So the main solution is basically a proxy server, and I'm going to tell you guys why is this helpful at basically preventing a DDoS attack. Now imagine a proxy server is basically going to act and is going to be in front of the web server, like a protection for it. So all the requests that come it'll hit the proxy server first rather than the web server. The proxy server will then identify that this is a type of a basically DDoS attack, and it will not let these requests be sent to the web server. So the web server will still be able to continue to respond to the original requests. The proxy server has other features as well, but in this context, this is its main purpose. Question number 9 says a company uses both solid state and optical secondary storage. Explain why does a computer basically need a secondary storage? 2 marks, or at least 2 reasons for it. So one reason for secondary storage can include HDD, SSD, so the largest storage that you have in a computer. The main purpose of this is to store your data or files permanently, because any data stored in the RAM would be deleted once your computer is shut down. So secondary storage is required. You need secondary storage to store. You need secondary storage to store data or the files permanently. Otherwise, basically, if you do not store them permanently, that means you will need to install them, or you need to get them from every time you need to open the computer. And also, the one more purpose could be you also need to allow software to be installed, because all of your software resides on the secondary storage, because they're often a very large size. The secondary storage is required to store data and files permanently, and you can also say allow software to be downloaded to the computer or to be installed, you can say, because software would often install terms, software to be installed on the computer. Alright, just want to explain it once more. A computer basically needs secondary storage in order to store data and files permanently, and also to allow software to be installed. Another reason that you could mention, which I have not mentioned, and which would be correct, is you basically need to get virtual memory. Now, virtual memory is an important concept, and it's used when your RAM gets full. So some of the data from the RAM will be moved on to the SSD or the HDD, and whenever you need the data, you just swap it with something in the RAM, so that you're basically, then you have a larger RAM. You don't need to purchase more expensive RAM. You can run larger programs than the RAM size. Then it says describe 3 differences between a solid state and optical storage. And as for 6 marks, so solid state, you have SSD technology and optical storage, including CDs, DVDs, and Blu-ray discs. Now, the first one of the key differences is that solid state does not have any moving parts. Your data is stored, basically retracted using gates. You have your NAND gates and NOR gates along with transistors. Whereas for optical storage, these devices are often rotated. So that's one difference. That is, solid state does not involve any moving parts, whereas optical storage involves moving parts. So that's one of the key differences. Moving parts, as in CDs, DVDs, and Blu-ray discs, they rotate, but in solid state it does not, because your data stored as being electrons. Right. The second thing is that solid state is often basically faster to access the data, again because there are no moving parts. Everything is being done using electrons and your transistors and gates along with being current. So that makes it overall faster to access the data. Whereas optical, because you need to rotate, it becomes slower to access the data. So you can say that solid state can access data faster compared to optical, which is slower at accessing the data. So these are the 2 differences that might land me 4 marks, because 1 mark for each point. You can also say that basically solid state has a larger storage capacity, whereas optical has a much smaller storage capacity. So because solid state, you have 1 TB, 2 TB SSDs, whereas optical might be, the Blu-ray would be the highest in terms of optical, and allows you to store up to 75, around 50. But solid state is way beyond that. So that could be my third advantage. That is, solid state storage has a larger storage capacity, has a larger storage capacity. When it could talk in terms of storage capacity, solid state is way larger, whereas optical has much smaller limit of its storage capacity. Solid state is larger, optical is smaller, and then solid state can access data faster, and solid state does not involve any moving parts. I hope this part is also clear. Now we will move on to question number 10, which says that, now this is a part of AI. It says that a garage uses an expert system to help diagnose any problems that need repair. any problem that need repair. The expert system is an example of artificial intelligence. Describe what is meant by AI. Now, first of all, let me tell you what is AI. AI is basically the simulation, as defined by the textbook, the simulation of intelligent behavior by a computer. And first of all, you're gonna write that AI refers to the simulation. You try to simulate the simulation of intelligent behavior like thinking skills, or that is expert systems where it can think like an expert, a human expert, or also judging skills. Simulation of intelligent behavior by, okay, why have I spelled behavior wrong? Behavior by a computer. All right, it has the ability to reason. Basically, reason means to provide reasonings for the data, and also it does learn. It has the ability to learn and adopt. Now this is 2 marks. I'm just going to write one more point. It has the ability to learn or adopt. Now, when I say learning and adopting, it basically means that as you provide it with more data, it learns from the data and then it will get better at its responses on the next time you use it. AI is basically you try to simulate intelligent human behavior by a computer. It has the ability to learn or adopt, basically depending on the data. Learning is also done when you're training the program itself. Now, it says that a car has a problem with the braking system, so it's brought into guide to explain how the expert system operates and how it will be used. Now, the expert system is basically very simple. What it does is that first of all, you're going to enter all the data using the inference, using the interface. Now, this data will be matched in two types of data, which is called as a knowledge base and the rule base. Knowledge base stores all data about, like for example, the car, whereas the rule base will involve inference rules. So try to match these using the inference engine, and then finally they'll provide you a conclusion. There's also an explanation system which explains the reasonings and like how has the AI system came to certain conclusion. So first of all, maybe you can say that the user will enter the data into the interface, which is called as a user interface. The user will enter data. The user will enter data into the interface. You will enter the data into the user interface. That's your first point, interface. Now these, when you're entering data, often it is basically yes or no questions which are asked by the inference engine itself, and these questions are dependent on, for example, you answer question number 1, so when you answer question number 2, it's dependent on your answering question number 1. The user will enter the data into the user interface. The inference engine will decide which questions to ask by using the previous answers given. So once you answer a given question, the next question will be particularly dependent on that. So that's a point you can include, that basically you have the inference engine. The inference engine will decide on questions, will decide on the questions to be asked, will decide on the questions the inference engine will decide on the questions to be asked by using the previous answers given. By using, like, whatever previous answer responses you give, your questions will depend on that, by using the previous answers given. Now that is basically the first step that involves entering the data into the user interface. How many marks do you have for this question? 5 marks, at least 5 points. These are only 2 points. Then it will basically decide on the diagnosis. How will it diagnose the problem? It compare the data or the answer that you have provided, entered, to the knowledge base, which has all the data, and the rule base, which has the inference engine. So that's going to be my third point. The inference engine will basically decide on the diagnosis, will decide on the diagnosis. Diagnosis will involve what is the finding out of the problem in the car. How will it do it? By comparing. Now comparing two things here, comparing the data responses, the data or the responses which are provided by the user, in the user interface that are basically entered with data on knowledge base and rule base. With the data on knowledge base, and the rule base. Then after you find the diagnosis, it will output it, and it will output the diagnosis, and then you will use the explanation system, which has not been covered in depth, but we do know that the main purpose of the explanation system is to show that how the diagnosis was reached, so like on what basis. The interface, like the main interface was asking questions initially. Now it will output the diagnosis, it will output diagnosis, an explanation system, which is not covered, so you can skip this point if you're not understand it. Explanation system will basically show you, explanation system shows how the diagnosis was reached, I'm going to quickly repeat this. Basically, how did it decide to diagnose a problem? The user will first of all enter the data in the user interface, and it will be dependent on yes or no questions which are asked by the interface, and the questions asked are dependent on the answers of the previous questions. It will then decide on the diagnosis by comparing the data responses that you have with the data on the knowledge base and the rule base. Whatever data responses that you have entered, compared to those on the rule base. Then it will output the diagnosis, and the explanation system will explain then how has it reached to a particular diagnosis. Moving on, I think this is the last question that we have on this paper here. So it says that describe the differences between the internet and the World Wide Web. Now, the internet is basically just an infrastructure. It involves a number of connected devices and internet around the world. Whereas like a World Wide Web is a collection of web pages, and this is basically a service which has been provided by the internet. So what we're gonna say is the internet is like an infrastructure, involving a collection of, no, basically you can say involving a network of devices. Internet is basically a network, right? Okay, I guess I was right here. Internet is an infrastructure involving a connection of devices which are directly connected to the internet, in a connection of devices and networks throughout the globe. So you have different devices and networks which are all connected together using the internet. Indeed, the video you're watching now is also a part provided by the internet. The World Wide Web, however, is a collection of web pages which are grouped together to form websites. Collection of web pages they are stored on the web server and accessed. How are they accessed? And accessed using what type of software? This is basically called as web browser. So the internet is the main infrastructure at the frame which allows us to do many other services, including emails, and then video calling, or all the other most of the services that use the internet. The World Wide Web will be like a part of the internet, and this involves basically all the files that are stored. You have these collection of web pages that are stored on the web server and accessed using web browser. Internet, the main infrastructure behind the computers, and involves all the devices and networks like LANs being connected together to form the internet. The World Wide Web, however, is basically all of the web pages that you see, all the websites that you use. Basically World Wide Web is just all of these web pages, collection of web pages, and where are they stored? They're stored on web servers. And how do you access them? You use a web browser like a Chrome or Edge or Safari in order to access these websites. Now, in order to extract the data, for example, when you request the data from the web server, the internet is used. So that's why the www, the World Wide Web, is a service which has been provided by the internet. The website has a URL. The URL is three different parts. Identify the three different parts that are included in the URL. So URL will have a protocol. Now protocol can be an HTTP or HTTPS, and this is refers to the rules that you use that should be followed when you're using the internet. You have a domain name that includes basically the name for the website, as well as basically a file name. Now basically, because a website is often large, so apart from domain name, which exact page are you referring on, that will be the file name. One function of a web browser is to provide an address bar for the user to enter URL. So whenever you open any web browser, you have an address bar to put the URL. What are the three other functions? Now another function could be basically that you have storing cookies. Storing cookies. Now what you have in storing cookies is that these cookies store data about the user. They can be permanent, they can be persistent, or session cookies, and they try to improve your experience. I'm not going to go in depth because it's a different topic altogether. Storing cookies, allowing the use of multiple tabs. Multiple tabs, you can open multiple tabs and use them at the same time. Multiple tabs, that's another feature, as well as they keep a record of the user's history. So these are the three: recording users history. You have more answers for this. For example, you can base it a home page or navigation tools like forwarding or backwards, and then bookmarks or your favorite pages, also displaying a web page. So these are all the answers. And by finishing this question, we have finished this paper. I hope this video was very helpful for you guys, and I hope I hope you've understood all the questions. If you have any doubts, you can please post them down below, and I'll reply to them as soon as possible. If you do have any suggestions for any papers that you want solutions on, please do comment down below, and I'll try my best to make the videos for them. Best of luck for your upcoming October-November 2024 exams, and do not forget to like, share, and subscribe to my channel. Alright, peace out. See you in the next video.